Okay, good afternoon, everyone, and welcome here. We are starting. I was just trying to see if I can get more students joining in, but I'm thinking that may not be happening. So we will continue from where we stopped. Today we are looking at data preprocessing. Just wanted to confirm how many people are still part of this class. Data preprocessing is the area that we want to focus on today. Just to think through some few thoughts in there around data preprocessing, but also to engage and see how this can be applicable in our day-to-day world. Because anyway, we are in a world of data, so it's very important. I am not sure if there is any students, I don't know if we have students here we have not met before, because I have seen the numbers just skyrocketed or something. There are many more who joined. Yes, but nevertheless, we will just continue. Please make sure that you try and pick up. I don't know if there is any one of us who has tried to access the recordings of these collaboration sessions that we have had before. And have you been able to access them? I would want to know if that is possible, or do I need to download them and share them on the dashboard? I need to know that. So maybe from the chat box, I can get feedback around about that. Are you able to access, like, for example, those who are not there in the first session, are you able to access the recording of what we did, so that you can go through it as you go through the notes that I am posting? I don't know if that has been possible. Okay, it's possible. Thank you, Stacy. So we will continue. Anyone who is not able to join us, they will try and catch up through that. But of course, like I said, we need to note that attendance is purely based on our attendance of this collaboration session. And so you know the policy. This is system, so there is no going around about it. It's the system that is going to say you are in or out. It's not me. So let's take care of that. But yeah, we talked about some few concepts around data mining, around data warehousing last time, and just trying to introduce ourselves to what that means to us. And part of that was just to understand, why do we have data mining? What's the importance of this? But also we were trying to also differentiate between data mining and data warehousing, and just looking at what are some of those systems that are used in data mining and those that we can be able to use in data warehousing, and what's the difference in there. And I think, if I remember well, some of the things that were coming out very well was, when we talk about data warehousing, then we're looking at historical data that has been stored over time. We are looking at subject-oriented data. We are looking at, data that is varying with time, okay? And all those features that we looked at in data warehousing. But also in data mining, we were looking at extraction of data to make meaning out of the data that has been collected over time, or out of the data that is currently running on a transactional database. Yeah, so that's very important. But today we wanted to look at data preprocessing, and this basically is, before we can make meaning of data, we may need to look at it critically and see, is it giving us a true representation of what we are looking for? Is it giving us a true representation of what probably has been there before, what has been looked at before, or what we are looking forward to. And some of those is just, there are some of the things that we know they are for facts that you can't expect data that has been collected and the age of a person is reading at 300, for example. And so there is always a need for us to look at how can we, look at the data as raw as it is, but also be able to dive into that data and do some few things to make it relevant for us to make meaning out of it. And so some of those things are things that we have given definitions around them. Data cleaning, for example. So removing of noise, adding of missing data, ignoring some of them, but also data transformation, which I know in databases, for example, you must have looked at normalization, yeah, two-factor form, normalization, and all those that you looked at. Attribute selection, um, discretization, but also concept hierarchy generation. And then also we have data reduction, and this may be informed by the fact that we may not say we want to reduce data because we are not the only reason we would want to do that is, are we able to maintain, to sustain the meaning that we wanted to deduce even after doing reduction? So reduction may be attribute subset selection. It may be just different attributes are being used, or we are using different names to refer to different attributes, and we want to cut down and scale down, or we want to merge and just get the right data. And if you remember last time as we were talking, we said that, for example, you may be collecting data about students, and you find that in ZTech University, we call students number, we call them registration number. But if you may go to another university, that is called admission number. Another university calls that maybe, let's say, student number. And if you collect data from all those universities, you find that the data that you get is actually, in one way or the other, it's going to have all those attributes reading different, but in actual sense, you are referring to one thing. And so there is need for you to merge some of those things. Very, very important. So we will be just looking at this in details in today's class, and see what we can be able to learn out of this. So, so some of the steps that are involved in data preprocessing, one is cleaning, whereby data can be can have many irrelevant and missing parts. And it's very, very important for us to do cleaning. And that can be, can involve, for example, looking at what is missing within the data and knowing how to deal with that. So some of the missing values may be requiring you, for example, to construct new attributes if that is needed, or it may require you to ignore some of the attributes or some of the data that is in there. The other thing is also removing of the noise, and we talked about noise within data, which is just data that is meaningless. It may not add value at the very end of the day to the exact content that you are looking for. Because remember that at the very end of the day, we expect that the data that we get at the end of the day is informed, or we are proactive, let me say that, in our data mining process, it's a proactive, venture whereby we know the end goal of the meaning we want to deduce, or we know what we are looking for. So you set goals and say, by the end of the day, I want to establish who are the customers and where do they come from, who buy this and these products. And so out of that, you now come up with data attributes that can help you, get the results that you are looking for. So you have the goal in mind, the end goal. You must have that in mind, even as you start the process. And so, whenever you collect data that probably in one way or the other, it may not be giving you the exact thing that you're looking for, then it's important for you to deal with that. Because at the end of the day, if it's not dealt with, it will give you, or rather, you'll have results that are not mirroring what you are looking for. So things to do with binding method, which is a method that works on sorted data in order to smooth the data that is there. So a whole data is divided into segments of equal size, and then various methods are performed to complete the task. And each segment is handled separately. And one can replace all data in a segment by its mean or boundary values that can be used to complete the task. The other one is regression, and probably that one is more or less closer home. And in this case, data can be made smooth by fitting in to the regression function. So you know the behavior using a particular function, you know the behavior that you expect. And I know this is more like what we were talking about earlier on, line of best fits, independent and dependent variables, and just looking at this is what I expect at the end of the day as far as this data is concerned. And so any data can be fitted into that particular function that you have. Also clustering, and this is an area that we'll also focus more on, whereby you can cluster data into particular clusters. And so anyone that doesn't fit in that particular cluster becomes an outlier. And so you can deal with that either by removing the outlier or by knowing why do we have it as an outlier and how can you be able to deal with that. The other thing is on data preprocessing is also data integration. And this is more of combining of multiple sources of data into one coherent data store. Remember, by definition, we say that the data that we are dealing with in data mining is coming from multiple sources. And so there is a need for us to combine that. And some of those combining is, for example, like the image I have on the screen right now, where you have multiple sources, source A, B, and C, and you have a wrapper that helps you to wrap this data and this one and this one, and put that data in one particular storage. And so that's also very important because at the end of the day, we would not want, let me give an example of Google, which is key, or they are strong in data analytics. You don't want to have Google mining your data from all those sites that you visit and you sign in with their email address. You don't want them to mine that data and put each one of them in different places, but you want them to be able to combine that data together about a person, about a particular customer, and store that data all together in one place. And that's very, very important. So, the issue of just, combining data together, integration of data together into one particular database, which may be a warehouse where you want to store that data over time, or it may be just, one repository where you want to derive your meaning of that data from. But whichever the case, it's important for us to note that, because like I was saying, you don't want to have so many attributes that essentially they mean the same thing. You don't want to have that. And even as we continue, I can see a number of us here. Let me confirm that we are still together. Robert, are you still there? Robert, okay, I can see you typing. Susan Opondo, are you still there? Susan, are you still there? Philemon, are you there? Naftali, Jamila. Okay, okay. At least I can confirm we are still together. Okay. So that's very important. The other thing, so you're saying integration is key. And so even as we look at, because from our next session, I would want to start off with association rule mining and just looking at a few computation in there around association rule mining, and just introducing ourselves to the concept before we dive into which I would want to do towards the end, just looking at the emerging trends where we are at today, so that as we talk about association rule mining, we can understand the historical perspective of it, but also we can get closer home into how that is being applied today. What are some of those issues that may come with data integration? Part of that is just matching of objects. So how can the data analyst or the computer be sure that the customer ID on one database and the customer number on another database is actually referencing the same attribute? That can be a challenge, and that's something that we may need to think about, because in different contexts, we may call particular attributes differently. In different databases, we may have a particular entity referred in a different way. And so when we are integrating those, we may need to be very careful, even by just engaging the stakeholders and getting to know what exactly do you mean in this database when you talk about a customer ID. What do you mean? When you talk about a customer number in this database, what do you mean? So that integration can be a challenge, because each and every database may be using their own schema. They may be using their own way, different naming conventions. And so we need to be very careful about that. The other issue that you would expect, of course, without even saying, is redundancy. Because an attribute such as, let's say, annual revenue, for instance, may be redundant if it can be derived from another attribute or set of attributes. So you know that if you have age and you have the date of birth, you can derive the age. I mean, if you have the date of birth, you can derive the age using today's date for someone. And so we want to be sure that we are not causing redundancy. And remember, when I talk about redundancy here, I'm not talking of redundancy where we replicate databases for security reasons, because we do that quite often, even in data warehouses, where we want to have this particular database replicated so that if we have a downtime for one database, then the other one can pick up. That is not what I mean. What I mean by redundancy here is that we have attributes that are referring to the same thing, but two or more attributes that are still referring to one thing. And that in itself can cause a lot of inconsistencies, because we would want to, you remember in databases, you must have looked at acid properties. What does acid properties mean? Those who are here, yeah? What do we mean by acid? A stands for what? C stands for what? I stands for what? D stands for what? Those who did database, I bet you must have looked at acid properties. So atomic stands for atomicity, correct? C stands for what? Okay, C stands for consistency. I stands for what? And D stands for what? So what we are saying here is even those that we have used in in databases, in other databases that we have used, concepts that we have used before, they are very, very important even in this space. That we need to ensure that those concepts are actually achieved. So A for atomicity, C for where was I? Consistency, okay. I for isolation, and D for durability, correct? Yeah. So, and that's very important because even in this space, when you talk about redundancy, you don't want to have, a transaction that is referencing two or more attributes within a data warehouse or within a database. May it be a transaction or database, may it be, a data warehouse. At the very end of the day, you want to have consistency in how the naming. So that's why we were even talking about things to do with, things to do with, what did I call that? The issues of consistency in naming conventions is very important. I think the concept I wanted to repeat as is keeping my mind. But yeah, right here, yeah, we were talking about normalization. Sorry, that's what I wanted to refer to. Normalization, which is also a concept that helps us to deal with redundancy from database perspective. It's a concept to deal with redundancy, and it's very important. But also detection and resolution of data value conflicts. So for the same real world entity, attribute values um, from different sources may differ. You may have a particular entity, and the attribute value within that entity is different from what the perspective of another database looks like. And we may need to look at that. So those are some of the issues that we need to consider, especially when we talk about integration of course, we may not have exhausted all. And if you have some that we can add to the list, please feel free to leave a comment on the chat box so that we can also discuss that. But also, of course, if you have any question. But we are saying, let's try and resolve those issues as we integrate data, as we pull data from multiple sources. Let's make sure that we are able to integrate, we are able to ensure consistency is achieved, we are able to ensure atomicity is achieved, isolation is achieved, but also durability, of course, it's something that we cannot run away from, especially when we are talking about data warehousing. The other thing is data transformation. As a concept in data pre-processing, which is important to us. And this is in data transformation, data are transformed or consolidated into forms appropriate for mining. Now, this may be query or entirely dependent on the data mining engine that you are using. Because that may inform the data values that you want to use. It may inform the, the attributes of those data values, or the naming conventions that you want to use. It may inform a lot of things. And so this may involve things like smoothing, which we talked about. We want to remove the noise within the data, and things to do with regression, clustering, some of those ways that we can use to remove noise within the data. Because if we are talking of cluster A, B, and C, and there is a particular data set or a particular attribute of a data that is not falling within our clusters, then it's very easy for us to assume that that particular attribute is actually an outlier, and we can do away with it, or we can treat that as noise within the data. Then the other thing is also aggregation, and where summary or aggregation operations are applied to the data. And for example, this could be the daily sales data may be aggregated into a monthly report, yeah, and that happens a lot. Susan, I would want you to keep your mic muted as we continue. Yes, please. Okay, so aggregation is also important. The other thing is generalization, and generalization of data may be based on what is supreme within that data. So you can generalize the data based on the supreme attributes of the data that you have, but also based on what is the end goal that you want to have at the end of the day. What is it that you want to achieve out of that data by the end of the day? And that's very important. Normalization, I may not talk a lot about this. You must have looked at it in databases, but basically very important is to ensure that attribute data are scaled so as to fall within a specific range, but to be able to lower that range to a particular level. Attribute construction, or something we call feature construction. And this may be you have different attributes, but you want to create new attributes where you construct those attributes and you add them within a given set of attributes to help in the mining process. So let's say, for example, I saw this with Ministry of Health. Those who have worked with Ministry of Health, if you are here, you can maybe contribute. Those who are in the health sector, yeah. There is a system within the Ministry of Health that is called DHIS. I don't know if there is anyone who has interacted with DHIS Kenya here. Maybe you can, if there is anyone, you can talk to us so that we can maybe engage together and see. But one of the things that is there in that system is it's basically a health information system, of course, but one of the things is they try to capture the records of health facilities within the country, and what they do out of that is also the reporting procedure for health facilities is based on the DHIS system, and I think it's what I have right now. Let me just share my screen for you to see what I think they are changing the name to KHIS. But either way, what we have known before is DHIS. If if I was to share my screen, this is what I mean. So what I needed to demonstrate around this is, for example, what is the attribute? What is the particular unique attributes, unique identifier for a given health facility within, within this system? Yeah. And so if you are to mine this system, this data, and probably you want to be able to see the reporting procedures and how well the reporting procedures are being followed. Because one of the things that happen with the Ministry of Health, of course, the funding comes a lot from World Health Organization and other platforms, World Bank and many other. And so they will always be keen to ensure that the allocation of resources is based on data. And so they may come into such a system and see which are the counties that are doing well in the reporting procedures that are defined in this particular system. And so those are given more funds comparing to the other ones, based on if you are doing well in reporting, then you are doing well in serving people, Kenyans. And so we can give you more money, expecting that the Kenyans are going to benefit. And so if you are to mine this data, and maybe you want to compare this data with data that is in source documents within health facilities, then you may need to know what is the unique identifier here, and what is the unique identifier within the source documents, so that you can either construct an attribute that can be able to match or do a comparison between the two documents. What is real on the ground, but also what is on the system, and just comparing that to see, do we have correct information being fed within the system. But that's just maybe an example, a quick example that we may think about. Yes, as we talk about attribute, construction or feature construction within data pre-processing stages. So the other thing is, of course, reduction. We have mentioned about this, and this can be done in various strategies. Data cube aggregation, where aggregation operations are applied on data in the construction of the data cube. And remember, the data cube in this case may be in one way or the other viewed as a cluster of data, but also attribute subset selection, whereby irrelevant, weakly relevant, and redundant attributes or dimensions may be detected and removed within the data that you are dealing with. The other one is dimensionality reduction and numerosity reduction. So dimensionality here is where encoding mechanisms can be used to reduce the data set size, as long as, and this I need to emphasize, as long as you are not tampering with the end goal that you have for your process. If it's a data mining process, it's important for us to have the end goal. And some of you, I know you'll be finishing this and you will get into consultancy, research consultancy, for example, or some of you may be in that space. And some of the things that, if, for example, you are to do business with the government in that space, one of the things that they will ask you is, give us an inception report, something they call inception report, because they want to see, do you really understand what we are asking for? And that informs them to know, can we give you this job? And if we give you this job, are we able to see clearly an inception report that tells us from A to Z, this is how the process is going to be executed? So, so things to do with So things to do with cube data cube aggregation, attribute subset selection, but also like I was saying now, the issue of dimensionality reduction, and looking at if I reduce this data to this level, do I still get to meet the end goal? And so the end goal must be well defined right from onset before you even get into the data mining process. Also, the other concept is discretization and concept hierarchy generation. And this is where raw data values for attributes are replaced by ranges or high conceptual levels. And data discretization is a form of numerosity reduction that is very useful for the automatic generation of concept hierarchies. So, those are some of those data pre-processing techniques that we can be able to use, and just of course sampling a few. I may not be able to finish all of them, but just sampling a few to see that this is a very important concept that we may not leave out if we were to achieve, high level of accuracy in our mining processes, but also even in data warehousing process. Because before we do warehousing, we need to, some of those things will be just even things to do with attribute subset selection, things to do with even, ignoring or reducing or constructing new attributes that can be able to fit within the data that we want to see at the end of the day. So those are some of the thoughts that I wanted us to I don't know if I'm breaking for all of us, or am I clear? Please, someone else confirm that I am clear or not, so that we confirm if it's Kevin. Okay, I think it's Kevin. I think Kevin, check your connection. You might be having some issues. Yes, let me hear if there is any question from your side. Let me know if there is any question from your side. Now, next week, I would want to start off with just looking at some few algorithms. So this may come with some a bit of let me say computations, just to look at from a concept level, some few algorithms here and there around what we are covering, and specifically starting with association room mining, which is one that is important to us. But the most important thing, if you remember, those who are here when we were beginning, one of the most important things that I said is that you may need to move from a conceptual level of learning to an application level, where you can even see how can a system be created that can meet some needs within your area or domain of operation on daily basis. So I am really calling us to, whenever we are learning some of these concepts, think about what is it that you can apply in real world or in real life, so that it's not just, concepts, you read the notes or you cram them and you pass the exam, but we can be able to see that this is something we can apply. But also we can ignite some of us here to become data scientists. I don't know if all of you checked this site. I talked about this site. Who has checked this site? CognitivePlus.ai. Who has checked that site? It's actually a product of IBM. And they have just amazing courses in there that you can take around data science, around data mining, just, let me say, just around what we are doing here. But also I realized the concepts are not anything, far away from what each one of these companies are using. Yes, they teach about data science. Yeah. So if you want to learn more on data science, that's a place. But I don't know if that was a question or you are answering, Hassan. But what I'm saying is data science and data mining is actually a subset of data science. The bigger picture is actually data science. So, okay. If it's a question, yes, they are. Let me even just open this because I know this can be a game changer for one or two of us here. So it's more of cognitive computing and data science. Let me share my screen because I would want any one of us here to consider. Take one or two courses. Otherwise, before you finish school, I don't know what would differentiate us from other graduates, and graduates are so many from many universities. I'm talking of these sites. So you can take free courses, just sign up and take free courses here. If time allows in this semester, I will actually make it a compulsory affair. That's each one of us will take a course there, and I'll grade you based on that. If time allows me. But yes, it's very important because at the end of the day, it's not just what you learn or what you hear me saying. All these things that we are talking about here, you can learn them by your own. It's possible. Yeah. But also, one of the very interesting things that I noticed is that actually the concepts for example, they are talking about their courses around Spark, around MapReduce. Now, if any one of you here will take a certification by Huawei or any other people out there who are certifying people on data science or big data, all those concepts are actually given here. Yeah. So the concepts of MapReduce, which is used by Google a lot, and the concepts of Spark, Fusion Insight. I think there is a course on that, which is a platform by Huawei. Yeah, so there are so many concepts in there that you can learn, to be very honest with you, and you can finish this season being better. But also, just to say that at the end of the day, the question will be when you go and you want to compete favorably with someone on an interview, what is it that is different that you are offering? That is the whole difference here. It's not about I have a degree. It's about I have a passion in an area, and I think I have been perfecting this area, and I think I'm good. Yeah. So it may be just that, and you may need to also know that. Okay, let me not start logging in there. But okay. So Susan, I can see you have a problem with your connection. I would want to end our collaboration here, 41 of us. Yeah, for today. And if there is no question, then I would want you to engage further. One is let's share. I'm just working on that discussion forum. 1 minute. But I just want us to share on give two takeaways from today's class that you have learned. It may be just your own, what you have deduced from what we have discussed, but I would want you to give two takeaways. Share two takeaways from today's class with you share with your classmates. So this is lecture 5 discussion forum. I hope this system will work for us. And it's true. So 1 minute, let me post this that you see. It's able to post. But also, I would want to take attendance for all of us who are here. One of the easiest ways I've seen working for me is just type a comment on the chat box. I'm able to pick your names very easily from there, as opposed to elsewhere. So the way all of those people, Akina Hassan, Kip Koskei, and others have typed, yeah, just any comments like what Michael has done, any comments. Then I'll pick your names from there. But also, I'd want you to go to the discussion forum that I've created and share two important or two take-home points that you have picked from today's class. Share that with your classmates. You just reply to the topic that I'm creating now. So reply to that forum that I have posted. I hope you can see it from that end. Okay, I think that is all. So once you post, you can feel free to interact with the other materials that are available there. But also, I would interest you to just go to cognitiveclass.ai, check in there, see some of the courses they are offering, see which one can you take, a self-paced course that you can take, and they will give you a badge, of course, to certify that you did the course and passed. Yeah, and that's the way to learn. That's the way to learn, of course. Yes. So if all of us have done that, then I can release us and see you in the next class. But before you leave, make sure that you have posted on the discussion forum. I'm waiting for those comments as well.